stuff. So chapter 4, I'd like to start by, if you could take and change this thing right here, change that y to a t. I use the variable y to stand for years, but that just messes people up. Then, so passed out these to you a little while ago. So 4-1, first thing in the notes. So basically, here's kind of what we're doing. The first line there, put numbers in for x. And it's not always an x. Sometimes it'll be a different letter, but basically it's the independent variable. So if you have an equation, I don't know if it's worth writing this, but I'm going to just make like a y equals 3x plus 2. We're going to be working with things like this today. The variable that's over here with the numbers is the independent variable. The variable that's by itself is the dependent variable. If our letters are x and y is typically going to be the dependent variable. It'll be y equals something with an x in it. That's way more common than having x equals like 3y plus 2. Fair enough? Okay. So x, or whatever letters over here with all the numbers, is the dependent variable. So put numbers in for this, and then find this one. Find y, which is going to be the dependent variable. And I'm going maybe a little overkill and trying to get you to come up with some of these equations, partially because it's fun. But this first one, I was trying to come up with what's an example. And this is something I found true to be in my life. But okay, the average weight W of a married male is 170 pounds plus 2 pounds for every year he's been married. My wife can cook. And I found out I was gaining weight like every year. It's like, okay, this trend needs to change, which you'll figure out when we're filling in the data table. But okay, so let's write an equation for that. The weight depends, the weight's the dependent variable, so weight depends on the time I've been married. How could we write an equation for how much I'd weigh after a certain amount of time? Go for it, Samuel.
Weight equals y times,
Great idea.
So if we take this, I'm going to put the 170 here. So if somebody weighs 170, fair enough? And now, is the weight going up or down?
Up.
So we're going up by 2, so that means we're probably going to add. And it's 2 for every year, so I'm going to put a t in there for the amount of time. So do you agree after 1 year the person's going to be 172 pounds?
Yes.
Which you get by doing 170 plus 2 times 1. After 2 years, the person gained 2 pounds twice, right? So it'd be 2 times 2. So it'd be 4 pounds, so it'd be 174 pounds. So when we fill in our data table, this W, this letter that's by itself, that always goes in the second row, because that's the dependent. And then T is going to be in the top row. And now the part I'm supposed to be going over is what we wrote up here. To put numbers in for the independent variable, put numbers in for T, and then find the dependent variable, these here. So if I take this 0, put a 0 in for T, 2 times 0 is
0.
plus 170? 170. So after 0 years of marriage, our average American male is 170 pounds. After 1 year, take a 1, put in there. Yep. So 2 times 1 is 2, plus 170. 172 is what I found myself. After 5 years of marriage, 2 times 5 is 10. It's 170. 180. And then realize, wait, this needs to change. Actually, that's probably more like around year 7 or 8 of marriage. But okay, so after 10 years, if the trend had continued, 2 times 10?
20.
Plus 170?
190.
190. After 25 years, 2 times 25?
50.
Plus 170?
220.
220. And suddenly I'm in the Clydesdale division of the Riverbank Run. Then 50 times T? I'm sorry, 50 times 2, 100. So now I'm 270. So this big old dude.
But that's after 50 years.
Some of you are like, it's worth it. 50 years of candy for 100 pounds? No problem. Okay. All right. Let's just keep going. Pay is $8 an hour. So we're trying to figure out your pay. If you get paid $8 an hour, what's that equation going to look like? P equals, go for it.
8 times 8H.
Nice, so 8H, or 8 times H if you want to.
So
And-
if there's no like a time in the middle, it's
If there's no sign, no math operation written in there, you assume it's multiplication. All right, and then P is by itself, so P is our dependent variable, so I'm going to put a lowercase p in that second row. And H, the number of hours, would be my dependent, because it's with the independent, so it's with the numbers. And now we just take these different numbers and put them in for H. So 8 times 2 is 16. 8 times 5, 40. So if you work for 5 hours, you get $40. 8 times 8,
64.
and 8 times 40, 320. So if you make $8 an hour and you work a 40-hour week, you get $320. Before taxes, which will take a lot of it. So, okay. Car salesman. Ready to keep going?
Yeah.
So last one like this, I believe. Car salesman earns $10,000 a year plus $200 per car sold. So what do you think we should do for the total salary? Should we do S for salary? Should we do P for pay? Okay. Maybe a capital S then, or you could do lowercase if you want. But salary equals, so now salary is going to be my lower line. And my independent variable is going to be what? What does salary depend on? Go for it, Samuel. Car sold. So what do we want to do for our other variable? C for car sold?
Yes.
Okay. So we have this 10,000 and we have the 200. Which one's kind of connected to the C, the car sold?
200.
200. Now do I connect it by addition or multiplication, subtraction, division?
Addition.
Maybe do this. If I get $200 for every car I sell, if I sell one car, I get how much money? 200. If I sell 2 cars, I get
400.
400. 3 cars, 600. Yep. So kind of like, what do I do to 1 to turn into 200 that I can do to 2 to turn into 400? Yep, do you agree it's 200 times those?
Yep.
So these were my number of cars. So our equation has to have a 200 times C in it, or a 200C. And now how do I connect my 10,000 to that?
Plus.
Exactly, plus or add 10,000. So we're saying the person's going to get this much money for working there, plus every time they sell a car, they get an extra $200. So if, we could put a C in there for our top row then, C the number of cars. If the person's like, sweet, I love this job, I'm not going to sell anything. If they sell 0 cars, they make 10,000, because this becomes 0, 200 times 0 is 0, but they still get the 10,000. They might want to look for a different job, though. That's not a lot to live on, and apparently it's not fitting their gifts. But okay, they sell 100 cars. Put 100 in there. 200 times 100. 2 times 1 is 2. How many zeros do you add?
30,000. Wait, no.
There's
20,000.
20,000, yep, because 2 times 1 is 2, then we have 1, 2, 3, 4 zeros. So that's 20,000 plus 10,000.
3,000. I mean 30.
30,000. So they're making 30,000 a year. Starting to look respectable. If they sell 200 cars, 200 times 200 is,
40,000.
yep, 40,000 plus the 10,000.
50,000.
They're making 50,000, making some teachers think, why am I not a car salesman? I went to do homework at night. Okay, $350. So 200 times $350,
700.
I think 70,000, right?
Oh, yeah.
So 70,000, yeah, the 70,000 plus 10,000,
80,000.
80,000, which is making a lot of us think, how come we're not selling cars? But anywho, sure beats babysitting.
If he sells 1 car.
So we're kind of turning the corner on this. We have 2 things I'm trying to get you to know. The first thing we did on page 1, I probably spent a little too much time on it, I suppose, but I could fill in data tables and give it an equation. I kind of made up the equations with you too, so we took a little more time for practicing that. The second part is, how do you find an equation that fits data in a table? And we've been doing that before, but we're going to take and give you some questions that are a little bit tougher this time around. By that I mean a little bit more fun this time around. Okay. If you have zeros, a lot of times, like, finding the equation from 0 to 0 does you no good. So I would just jump over here. How do you get from a 1 to a 7? You could do one of a couple things. You could, all right, I went the other way. You could do plus 6 or times 7, right? What works of those 2 to go from 2 to 14?
Times
So,
7.
yeah, plus 6 only gets you 8, but times 7 is looking good. Times 7 work there? Yep. So it works, times 7 works for all of those, right? So what we want to say is okay, I can get this bottom row, which is y, by taking my x value and multiplying it by 7. So y equals 7x or y equals 7 times x. Good? So So there's our equation for the first one. Now, some of these down below, between my 5, 6, and 7, maybe not all of them are going to be a little bit more complex. And here's kind of the hint for those ones that we go through and find out, oh, adding 6 doesn't work and multiplying by 7 doesn't work. What do? Then you kind of go to this. So if y goes up by the same amount each time x goes up 1, the equation will have y equals, and this is going to look kind of screwy, I'm going to say y equals that amount. And by that I mean the amount that y goes up each time x goes up 1. But y equals that amount times x. And I put a little space and then say in it. And that might not be real clear now, but after we do an example or two, it's going to become more clear. So don't stress about it yet. If we go back to what we were doing before, though, try it the old-fashioned way first, because if it works that way, it's just way easier. So we could get from a 1 to a 5 by adding or by multiplying by
5.
Okay, so now for 3 to 7, adding 4 still works, right?
Yes.
Times 5? No. 3 times 5 is 15. The next one, does adding 4 work?
Yes.
So we're looking good. Last one?
Yes.
Yep. So adding 4 works every time, so we could say y equals,
X plus 4.
nice, x plus 4. Because every time to find y, to find our bottom row, we just took the top row, the x, and we added 4. Good? So the next one is going to be where it starts not working. So the next one we have 4 plus 13 gets me 17, or 4 times 4.25. And if you can't do the 4.25 in your head, a way to find it would be to take 17 and do what?
Divide by 4.
Exactly. 17 divided by 4. If you do this divided by that, it'll tell you what the multiplier is. So we know we could have added 13 or multiplied by 4.25. Does adding 13 work here?
No.
Nope, because it get us up to 18. Times 4.25, that's going to be like 21.2? I think 21.2, so it doesn't work. Push comes to shove, grab your calculator, try it. Or sometimes jump over here. Do you agree this times 4.25 doesn't work? So it'd be 42.5. Or use a calculator. Okay, but none of these work. So that's where we get into a little bit of trouble now, because like these here, no good. So instead, go back up to this very top thing here. Let's see, does y go up by the same amount every time x goes up 1? So here, x goes up 1, y goes up by 5. Here, x goes up by 1, y goes up by 5. Ooh. Here, y goes up by 20. Does that mean the pattern doesn't work?
No, because it's times 10. Or times 5. Yeah.
Well, how much does x go up?
4 times.
X goes up by 4. So it's does y go up by the same amount every time x goes up 1? And if some of you are looking at like ratio kind of things, but now, do you agree if this is one step and this is one step, do you agree this is 4 steps? 4 steps of going up 5 is the same as going up 20. So if you go up 4 times, you have 5, 10, 15, 20. So it's still going up by 5 every time x goes up by 1. So now let's try an equation. So we know our equation is going to be y equals, because we have y as our bottom row, it's our dependent. And now we found that if y goes up by the same amount each time x goes up 1, y goes up by 5, right? The equation will have y equals 5, that amount, times x in it. So I know my equation has to have a y equals 5x. Are you with me up to there?
Yes.
Now that equation isn't going to work for all of these, because if I do 4 times 5, I get 20, right? If I do 5 times 5, I get 25. 6 times 5 is 30. Every time I multiply by 5, I'm off by how much?
3.
3. So I'm 3 too high. So if I want to have a correction factor, I put a minus 3. Because 4 times 5 is 20, minus 3 is 17. 5 times 5 is 25, minus 3, 22. 6 times 5 is 30, minus 3, 27. 5 times 10 is 50, minus 3, 47. Good? Last one. Oh, come on, you're loving this. Okay, so could try it the old school way, so it'd be plus 13 Or times 5 point anyone?
Or
I think it's times 4 plus 4.
no.
Apparently I'm going too slow. Plus 13 doesn't work because that would give me 17. Times 5.3 repeating doesn't work, so it gives me something messed up. I'd use a calculator. So we do y equals, x is going up by 1, x is going up by 1, y is going up by
6. Plus 6.
plus 6. And when x goes up 2, y should go up not by 6, but by 12. So my equation then is going to have y equals 6x. We okay on the y equals 6x? Now we just need to figure out our correction factor. 6 times 3 is 18. So we have to minus 2. And best to check that. A lot of times you can make a lot of equations work for 1 or 2, but if you go way over to the end, 6 times 7 is 42, minus 2 gives you 40. So in a perfect world, you check all of them, but we're done.